Sketch the graph of the rational function f of x equals 2x squared plus x minus 6 all over x plus 3. The first thing we're going to want to do when we graph a rational function is to find the asymptotes. So let's first look at the vertical asymptotes. And we have vertical asymptotes anytime that denominator equals 0. So a vertical asymptote, I'll say when that denominator x plus 3 equals 0. So solving for 3, we have a vertical asymptote of x equals negative 3. I will go ahead and put that in. Again, these asymptotes are not part of the graph. They're just guidelines, you can think of them. They're invisible lines. So I will sketch that line, the graph of x equals negative 3. It's like a border. Our graph will not cross that border. It'll show up on either side of it. It just won't go across it. Okay, we've got a vertical asymptote there. Next, let's talk about horizontal asymptotes or oblique asymptotes. This is when x grows very large in either direction, positive or negative. To find the horizontal or oblique asymptotes, you think about when x gets really big, what happens here? Well, if these exponents in the numerator and the denominator, or you can think of it as the degree of the numerator and the degree of the denominator, if those are the same, we can just cancel out these x's and just say 2 over 1. All right? That is the ratio of the coefficients. But they do not just cancel out. The degrees are not the same in this one, so we're actually not going to have a horizontal asymptote in this one because the degree is greater in the numerator than it is in the denominator. Now, if the degree were lower in the numerator, you can consider this. If we had something like, this is just an example, if we had x minus 5 over x squared. If x grew really huge there, x squared is a lot bigger than x, so this would tend toward 0 as x got really big. But that's not what we're doing. So that's the other examples that you may have seen where they say the horizontal asymptote is the x-axis or y equals 0. But here we're going to have an oblique asymptote. So to find an oblique asymptote, you will divide the oblique asymptote. So you're just going to divide x plus 3 into this numerator, 2x squared plus x minus 6. And our quotient, doesn't matter what the remainder is, but our quotient is going to be the oblique asymptote. So I'll say oblique asymptote is y equals the quotient. All right, let's start dividing. X plus 3 goes in. Let's see, what do you have to multiply by x to get 2x squared? It is 2x. 2x times x is 2x squared. 2x times 3 is 6x. Subtract, just like if you were doing this division with numbers. And what I like to do, we know we're going to subtract this whole thing, so I just change the sign on everything, because if I were to put parentheses and put a negative sign out there, a minus, it would change the sign of everything inside. So 2x squared minus 2x then gives us 0, and x minus 6x gives us negative 5x. Then we drop down the next term, or if we were doing it with numbers, the next number, or the next digit. What do we multiply by x to get negative 5x? That is negative 5. So now we have 2x times x gives, negative 5 times x gives negative 5x, and negative 5 times 3 gives negative 15. Again, I'm going to pull this trick of just changing the sign. That's the same as subtracting everything in the bottom. So negative 5x and positive 5x is 0, negative 6 and positive 15 gives positive 9. So this would have a remainder of 9, or we could say plus 9 over x plus 3, a little refresher on division. But we're only looking at the quotient here for purposes of the oblique asymptote. So I'm just going to write this, just to save some space, I'm going to write y equals 2x minus 5. That'll be our oblique asymptote. So let's graph that. We've got a y-intercept of 5, 1, 2, 3, 4, 5, and a slope of 2, up 2 and over 1. And I'm going to just take a couple of seconds to make some dots here so that we can get a nice line. It won't be perfect, but we'll get a pretty good look at that. Okay, this oblique asymptote. Again, this is not part of the graph. It's just an invisible line that tells us where the graph will not cross. Okay, good. We've got our asymptotes. Now, where are we going to draw this? Coming in from the left. Are we going to come in over here above the oblique asymptote, or do we have to be below the oblique asymptote? Well, an easy way to check is to just plug in -4. That is just to the left of our vertical asymptote. And that'll tell us if we're going to be above this or below this oblique asymptote. Well, f of -4, you can check it yourself, but that equals -22. So that's the point way down here, lower than this screen allows. So that means that this graph is going to be below. So this is a rough sketch. And we do know that it's going to curve back down here because it's not going to cross that vertical asymptote. So that's part of the graph. Okay, going on over to the right, are we going to be above or below the oblique asymptote? Is it going to go curve up like this, or is it going to go like this? All right, I'll get rid of those, and then we'll draw the real one in there. So let's test 0. That is a point that is to the right of the vertical asymptote. So let's see. We've got f of 0. Well, f of 0 equals -6/3 equals -2. So it's below the x-axis, but it is still above the oblique asymptote. So we know that value for sure. So I'll put that in there. And then this is a rough sketch, but it's going to look something like this. And you could, of course, plug in some more points to see if it went deeper in that V or not. But that's a rough sketch. It's going to shoot up to the right of the vertical asymptote and shoot down to the left of the vertical asymptote and look like this next to the oblique asymptote. So that is a way to graph at least one rational function.